ventilation is the V in that word HVAC. And ventilation is the part of the HVAC system where we control the flow of air, and we blow out old air and we bring in new air. Part of the reason we need to do that is to keep the oxygen levels up. As people are breathing, of course, they're breathing in oxygen, breathing out carbon dioxide, and so the oxygen levels in a building can fall. And then we have to worry about all kinds of pollutants, which can be pathogens, dirt, soot, chemicals, so that gets controlled with ventilation as well. The C in HVAC stands for conditioning, and we talk about conditioned air, and when we say conditioned air, we mean we are controlling the condition of the temperature, the air movement, the humidity, and how clean the air quality is. Here in the Western Hemisphere, humans typically think of these as the set points for the comfort range, and these set points are standardized by ASHRAE. So in winter we like our thermostat set here, and in summer we like our thermostat set here. We want the air not to be blowing too fast, and we want a medium amount of humidity, not too dry, not too muggy. Whatever method we use, all of our ventilation systems have these same components in them. And basically we have some way of getting supply air into the spaces. So air comes in and it enters the room through registers, openings in the wall and the floor. And then we bring in outside air, and we take old air from the rooms through return registers back to the system. So the whole thing has to be in a cycle, otherwise the air won't move. And as building designers, we worry about heat loss and heat gain. We try to avoid infiltration. We don't want heat escaping out or heat filtering in when we don't want it. And we do want to plan how we move heat and cool air around using our ventilation system. We were talking about supply air and return air and needing to keep the air moving. And part of that is the idea that when you're blowing air into a room, you may be just slightly increasing the pressure in that room. Depending on what your building occupancy is used for, you might want to have your room pressurized so that you don't let outside stuff in. Like if your commercial building is next to a chemical manufacturing plant, you do not want fumes infiltrating, so you would pressurize your rooms. If you, for some reason, you want air to slip in, then you would have your pressure be just slightly lower. Commercial buildings often have an economizer cycle where they preheat outside air or pre-cool outside air using heat exchangers before the air flows through the main system. In a building, these heating and cooling and ventilating systems are controlled by thermostats, and each thermostat controls an area called a zone. Part of the challenge of designing an HVAC system for a building is getting these zones balanced. Now, ASHRAE has a bunch of standards for how to keep air healthy for us. They have minimum rates of this and that, including how many air changes per hour and how many cubic feet per minute of air blow into your space. And we are doing this for health. We want oxygen levels kept up. We want carbon monoxide and dioxide levels kept down. We want the right amount of moisture. And we want to minimize mold and pollutants. And if you do not keep control of these mold and pollutants, you can wind up with a situation called sick building syndrome, where the people who use the building are physically sick when they're at work and then feel fine again when they leave work. That happens, and it's a big problem. So ASHRAE specifies how many cubic feet per minute should be in a space. And here are some calculations. This is from their air quality standard, the 62.1. They also specify how many air changes per hour. And an air change is, let me see. Let me give an example. Let's say there were 100 cubic feet of air in this room. That's how many cubic feet the volume of this room is. One air change would have 100 cubic feet of air leaving and another 100 cubic feet of air from outside coming in. That's one complete air change. And that's how we keep fresh oxygen in here and keep CO2 from building up. So ASHRAE specifies how many air changes per hour are recommended based on the occupancy. They also offer flow rates in cubic feet per minute. So a cubic foot is 1 foot by 1 foot by 1 foot. How many of those do you want flowing through your space? We also need to think about velocity. And in a crude example, if your system is blowing air too fast, it's going to make a whistling noise. And it's going to be uncomfortable. You're going to feel your papers are blowing around. You're going to feel cold because you have this air whistling past you. One thing I've seen in residential systems, I know we're talking about commercial, but in residential systems, sometimes someone will say, oh, well, I've got a forced air furnace and I'd like to replace it with a heat pump. So they pull out their furnace, they plug in a heat pump, and all is well, they think. Here's the thing. A furnace requires smaller duct sizes, smaller diameter or cross-section. A heat pump requires big ductwork. So when you put in a heat pump, in many cases, you need to replace the ductwork. And in old houses where they have not done that, when they put in the heat pump with the blower, the thing starts whistling like crazy. So we want to watch out for that. Our HVAC professionals will measure the velocity in feet per minute. When we have too many feet per minute, the reason we get cold, or if we have the right feet per minute, the reason we are comfortable, is that air moving across us cools our skin and the objects in the room by convection. That's a method of heat transfer. And if we've been sweating and our skin is moist, it also causes heat to flow out of our skin through evaporation. So air movement promotes that cooling. Finally, another thing that HVAC technicians think about is the fact that in a heating system, back inside the ducts, when they first come from the heating unit, that air is hotter than you want it to be in the room. But you blow it out of the supply register and it diffuses through the room and the room is comfortable. Likewise, in a cooling system, the air in the ductwork coming from the air conditioner or the chiller is colder than you want it to be in the room. And so there's a transition zone between the supply register and where the people are actually doing stuff. And so our HVAC technician will think about managing that transition zone as well.